Okay guys, we are on a new section, Logarithmic Functions. And this is chapter 10, verse 4, definition of logarithms. Okay, now you know we've worked with something like this. F of x is equal to 2 to the x power. We have a variable in the exponent, and this is called an exponential function. And it has a graph that looks something like this. Right? And it always goes through 0, 1. Now, we also learned that some functions have an inverse. And on a graph, it looks like it mirrors straight across this x or y equals x line. So it's going to come something like this. Something like that. Okay, and this would be 1, 0. An exponential function passes the horizontal line test, so it has an inverse. Inverse of x equals, what is the kind of function that will undo an exponential function? So remember, when you work the inverse of a function, you end up with x again. So we need to have some kind of a thing that once you plug in a number, it'll give us x back. Well, it is called a logarithm. A logarithmic function will reverse an exponential function. So let me show you what we're looking at. So here's what they look like. The log base 2 of x. Wow, okay, look at that. You can read it two different ways. The base 2, you got to have the base. See, there's the base. The log base 2 of x. So, let's look at this with some actual numbers. If I take 2 to the x power here, okay, and then I'm going to put my x and my y. Okay, now if I plug in 1, I get 2. If I plug in 2, I get 4. If I plug in 3, I get 8. Okay, right? 2 to the x power. Now, how does it work with a logarithm? If I have 2 to the first power, 2 to the second power, 2 to the third power, then I get those numbers. Now in this one, I'm going to take the log base 2 of whatever this thing is, of f of x. And it'll undo it. Okay, so for my x, if I plug in, here, let's actually just put this x. So if I take this and plug it in here, and I plug in the 2, because remember this is going to undo this, then I will get 1. And if I plug in a 4, then I will get 2. If I plug in 8, I get 3. So here's what's interesting. So 2 to the, let me move this out. Okay, so 2 to the third power is 8. And now the log base 2 of 8 equals 3. 2 to the third equals 8. 2 to the third equals 8. 2 to the fourth equals 16. Log base 2 of 16 equals 4. Now remember, this number is this. This is the exponent for this base. It undoes the exponential power, or the exponent function. So 2 to the 0 equals 1. Log base 2 of 1 equals 0. Let's do a little weirder. 2 to the negative 1 is 1/2. Log base 2 of 1/2 equals negative 1. 2 to the negative 1 power is 1/2. This is the inverse. Now let's generalize it. Let's generalize it. 2 to the k power is a number. Log base 2, this 2 has to be there. Log base 2 of n is equal to the exponent. The log gives you the exponent. Okay. Now, there are some things that we can generalize about this, about logarithms, that'll be really helpful. Since the exponential function is a one-to-one function, if I have b to the k power equals n, this is an exponential function, and it's one-to-one. So its inverse, log with a base of n equals k. This is also one-to-one. So that means that the log with a base b of some number is equal to log base b of another number. Then that means that m equals n. So this is only true if this is true. And so because of this, we can start to mess with things and come up with some rules. Okay? Here's the rules. They're on page 469 of your textbook. I'm just going to write them down and read them to you, but I want you to look at them too. Okay, now if I say that the log base b of n equals k, remember k is the exponent, and if I say that b to the k power is equal to n, we can do some substitution and we can get this. The log base b of this, because that's n, of b to the k, will have to be k. Does that make sense? Okay, now let's substitute another way. This is k, and so if I write b to the log base b of n, then that's going to be n, because I substituted k, which is this. Okay? And two other little things that'll be true is if I take the log base b of b, it's got to equal 1 because b to the 1 power is b. And if I do the log base b of 1, it's always got to equal 0. Anything log to the 1, because b to the 0 is 1. It's got to be 0. Okay, so let's look at how some of these problems are going to be for you. Log base 6 of 36 equals 2. Can you write this as an exponent form? 6 is the base. Log base 6 to the second power is 36. Let's try another one. Log base 2 of 2 equals 1. Write down the base, write down the exponent, and it equals the number. One more. Log base 10 of 0.001 is equal to negative 3. So 10 to the negative 3 power is 0.001. Alright, now let's see if we can do it the other way. Here's an exponential form. Can we rewrite it in a logarithmic form? Okay, this is the base. We're going to say log base 6 of 1 is equal to the exponent. Let's do another one. 8 to the negative 2/3 power equals 1/4. Okay, what's our base? Log base 8 of 1/4 is equal to the exponent. Okay, let's do one more like that. 5 to the 3/2 equals 5 root 5. We're going to write it as a logarithm. What's the base? Log base 5 of what? Of this. 5 root 5 is equal to the exponent. Okay, now we're ready to try actually solving or simplifying some things. So this says simplify. Log base 5 of 25. There's no equal sign, but can we simplify it? Yes. 5 to the what is 25? 2. So the answer is 2. Let's try this one. Log base 2 of 8 times the square root of 2. This one's a little harder. 2 to the something power is going to give us 8 times the square root of 2. So let's actually write it down. 2 to the something power is going to equal this. Now we know that 2 to the 3rd power is equal to that, and 2 to the 1/2 power is equal to that. So 2 to the 7/2 power. Okay, last one. 2 to the log base 2 of 7. Hey, that's one of those little rules, but let's figure this out. 2 to the something power is, oh, wait, sorry, backwards. 2 to the something power is 7, and the 2 to that power is 7. Okay, we got it. Let's do one more set of examples where we're going to have to solve an equation this time. Okay, like this. Solve. Not simplify, but solve. Log base 4 of x equals 3. This is the base, this is the exponent, and this is the number. So 4 times 4 is 16 times 4 is 64. X equals 64. Another one. Log base 3 of 81 equals 4. Oh, excuse me, x. Goodness. Okay, so x is the base, to the 4th power is the exponent, equals 81, and x is going to be equal to 3. Okay, let me know if you guys have any questions, and you should be ready to go for it. Thanks.